Okay, slope-intercept form introduction says that the Slow and Sloppy 7 had started getting pledges for their walkathon, and a pledge is the amount of money that people promise to pay per lap that the groupies walk. Some people decided to just give a donation instead of pledging. So combining all of her pledges together, Abby was getting $10 per lap, and she had already gotten $40 in donations. Penny, who was getting $30 per lap, had gotten $20 in donations. So we're supposed to write equations and graph the functions to find out how much each groupie would raise after 4 laps if they do not receive any more donations or pledges. Okay, so we should be getting pretty good at writing equations. Let's go ahead and look at the 2 variables that we are dealing with. We are dealing with laps and the amount earned. So let's call them L and A. So with that in mind, we are going to look at our 2 girls. Who's first? Abby. And we are going to, again, in order to write this equation, we are going to say it in our mind and then rewrite it. So the amount earned is $10 per lap plus the $40 in donations. So Abby, amount earned is 10 per lap plus 40 in donations. Now let's go ahead and try that with Penny. Her amount earned is $30 per lap plus the $20 in donations. So amount is 30 per lap plus 20 in donations. Again, we should be getting really good at that. So step 1 done. Now we're supposed to graph this. Again, making sure that we know how to label this correctly. The amount earned depends on how many laps we walked. So we know that amount is going to be our dependent and laps are going to be our independent. We'll go ahead and go by ones on our laps. Should get us to 10. And from the looks of our numbers, let's go ahead and go by tens for our amount earned. Just to space this out a little bit. We are going to start graphing linear equations, so I would recommend starting now that you start using a ruler for these problems, just because the more exact the lines, the better with your answers. Okay, in the past we have created tables, we have looked at intercepts in order to graph these. Now we're going to look at using the y-intercept and the slope together. So let's look at Abby. We're going to look at what happens when she just steps on the track. Without any laps at all, we know that she already has $40 in her pocket. So Abby, again, with 0 laps walked, she has $40. Notice where that is on our graph. That's our y-intercept. So looking at this constant number that we're adding to our variable, we know that this is our y-intercept. So there's the vocab word for it. That also tells us when we're graphing, this is the point where we start. So we're going to say starting point. So when we graph this, we're actually working backwards. We go right to left instead of left to right. Okay, so we know that she starts with $40 in her pocket. After 1 lap, how much does she have? Well, she has $10 extra. So she increases $10 per lap. Look what I just did. I rose $10 and I ran 1 lap. So looking at this number right here, this is the slope. And I'm going to put this over 1 for a minute because I rose 10 and I ran 1. So starting from the y-intercept, I'm going to rise and run whatever my slope is telling me to do. And those are the 2 points that I'm going to use for Abby. Remember to graph linear equations. All you need are those 2 points, and we're going to connect those dots. And this is going to be interesting with trying to do this on the computer. There we go. Let's not go so bad. Okay. So using those clues of what those points or what those numbers mean in order to graph. Okay, with that in mind, let's go ahead and try that with Penny. Again, without looking at these as actual laps and amounts, let's go ahead and just look at it as a graph. We understand that that 20 is our y-intercept, so that's where we're going to start. So we're starting at 20. Anytime that we look at that slope and it's not written as a fraction, go ahead and write it as a fraction, because that's telling us from that 20, we're going to rise 30 and we're going to run 1. So again, I'm going to go up 10, 20, 30, and I'm going to run 1. And there's Penny's graph. So go ahead and graph that. And there we go. 2 nice pretty graphs looking at those clues and using them to quickly plot 2 points. Okay, almost done. Now we're supposed to figure out how much each groupie would raise after 4 laps. Again, we are used to plugging in some numbers and figuring it out from there. But we have this nice graph now. What they're asking is, after 4 laps, where's the intersection of that graph? So I'm going to go up 4, and I'm going to see the value of the amounts. So looking at Abby, looks like she's right there at 80. Looking at Penny, she's right there at 140. So I'm going to say Abby has $80 after 4 laps, and Penny has $140 after 4 laps. So notice I didn't have to do any plugging in and solving there. I could just quickly look at that graph and get that information. And again, using that ruler really does help me, because if I didn't, my line might have been a little bit off and it would have been hard to see. So again, slope or y-intercept, and that slope we are going to use in order to graph these. We call it the slope-intercept form, because, and we'll get into that in the notes and vocab. So go ahead and get your notes and vocab out for this section. Okay, objective of this section is to graph 2 variable linear equations, which we know how to do, but this is another nice tip and trick to work with. Slope-intercept form says an equation of the form y equals mx plus b, where m is the slope and b is the y-intercept. We have to get used to seeing that, because you're going to see this equation many, many times. Again, this is called the slope-intercept form. The variables m and b are called parameters of the equation because they change. The y and the x are always going to be there. We're going to be changing the slope and the y-intercept. Okay. They give a good example there, but again, we looked at 2 good examples in the introduction. So we're going to jump right into example 1. It says we're supposed to first off write an equation in slope-intercept form for the line with a slope of 3/4 and a y-intercept of -2. Then we're supposed to graph the equation. I'm going to start getting used to that slope-intercept form. So I'm going to write it, again, y equals mx plus b. And I know that I'm going to put some numbers in for m and b. Then I'm going to see what they tell me. They tell me the slope is 3/4. So I'm going to start getting used to using that parameter m for slope. So I know m is 3/4. I know the y-intercept is -2. And again, I'm going to start getting used to saying that the y-intercept is b. Well, now I know the 2 pieces that I have to have for this equation. So I'm just going to fill in the blanks. Y equals a slope of 3/4 x. And then since this is a -2, I could say plus a -2, but I'm just going to say -2. Okay, so there's my equation. Now I'm supposed to graph it. Understanding how to graph this. So we are going to remember that this is our y-intercept starting point. So from 0, I'm going to drop to -2. This is my starting point. Then from there, from that point, this is telling me to rise 3 and to run 4. So I'm going to rise 1, 2, 3, run 1, 2, 3, 4, and there's my second point. Okay, 2 points is all I need to graph an equation. So let's go ahead and graph. And there it is. All right. You don't have to put that triangle in there. I just wanted to show you what I did because this is 3 and this is 4. So we understand where that slope comes into play. Okay, so again, get used to that M and B, understand starting point, and then work backwards. From that point, rise and run what the slope tells you to. Okay, go ahead and try that with the guided practice. Okay, these guided practice are a little bit different than what we've seen because of that negative in front of the slope. When we worked with slope before, remember that that means that instead of rising, we were dropping. So y-intercept is 3. From there, that -1 means I'm actually going to drop 1 and then run 2. So you might want to put that in there that I dropped 1 and I ran 2. Okay, so there's my -1 and there's where my 2 is. Looking at this one, y-intercept was -8. Of course, on this graph, it's really hard to drop 3. Since this was a whole number, I put it over 1. And I realized that negative means I'm supposed to drop 3 and then run 1. Well, kind of hard to do. I was off the graph. If you want to double check that, I can rise 3 and then go to the left one. As long as one of these is negative, you should be okay. But usually we always say that if it's negative, we drop and then run. If you can't, rise and then go to the left. Okay, so understanding negatives. One thing that students want to do on this is they want to drop 1 and go to the left 2. Well, if you did that, that actually means both of them are negative, and that's not true. Okay, and another thing, they're like, well, which one of these numbers is negative? Is it the 1 or is it the 2? Technically, it's the whole thing, but understanding that that just means that we have a negative slope. So both of these, you should visually see that both of both of my skateboards are going downhill. Okay, so that's how we throw in that negative. All right, looking at this next example, it says when an equation is not written in slope-intercept form, it may be easier to rewrite it before graphing. Notice how it says may be easier. Again, there's many different ways to graph equations. We need to start getting used to looking at what kind of form it's in and the easiest way to graph this. Notice that this is actually written in standard form. This goes back to one of the very first times that we actually ended up graphing. So if it is in standard form, this is when we should cover and solve. Cover and solve for intercepts. So much easier than having to spend a whole bunch of time moving things around. So we're going to, for just a second, we're going to do standard form, and then we're going to write it in slope-intercept form, and we're going to compare our answers. So if you remember how we did our cover and solve, in order to find, just a sec, let me get something that works here. In order to find the x-intercept, we got rid of the y, and I see that x equals 2. So x-intercept is at 2. So right away, I come over here and I hit that point. Okay, how did I find that? Again, I looked at 3x equals 6. I tried to get x by itself, so I divided that 3 over. Why am I getting rid of the y right here? Because on this point, y equals 0. Okay, now I'm going to do the same thing with when x equals 0. So I'm going to cancel out the x, and I'm going to see that y equals 3, because 6 divided by 2 equals 3. So when x is 0, y is 3. Using my standard form tips and tricks, I'm going to go ahead and try. It doesn't work well with trying to draw on a computer, sorry. Okay, so that's semi-decent looking line. Now let's go ahead and look at this in slope-intercept. Remember that slope-intercept is y equals mx plus b. So what we're trying to do is get y by itself. This goes back to literal equations. 3x plus 2y equals 6. I'm going to have to undo everything around this y. So first step, I'm going to add or subtract. I have to subtract this 3x over. So I have 2y equals. And notice in my equation, the variable piece comes first. So I'm going to say negative 3x, and this is a positive 6. Okay, I'm very close. I have to get rid of this 2. So I'm going to divide by 2. And notice I have to divide each piece by 2. So I have y by itself. I'm going to look at this 2 on both pieces. This is negative 3 over 2x. 6 divided by 2 is a positive 3. Okay, so I'm going to see if this is the same equation as that. All right, let's try it. We know that that 3 is our y-intercept, so we start at 3. Look at that. First point, good. Remember, this is a negative, so that means that I'm going to drop 3, and I'm going to run 2. So from here, I drop 3, I run 2. And look at that, same 2 points. And notice how much faster it was to use standard form, the cover and solve, because it was written in standard form. Okay, so that's one of my goals with graphing, is for students to look at what form it is and understand what is the best way to graph it. Do I cover and solve, or do I look at the clues of the y-intercept and the slope? Okay, so go ahead and look at these 2 guided practice and graph these. Okay, a quick eval, realize that each one of these are in standard form. So covering and solving, you could have quickly found the 2 y-intercept or the 2 intercepts and plotted those, or you could have written these in slope-intercept form to double check. Okay, moving on. Reading this, except for the graph y equals 0, which lies on the x-axis, horizontal lines have a slope of 0. They are graphs of constant functions, which can be written in slope-intercept form as y equals 0, x plus b, or just y equals b. Because again, our slope is 0, which means that we only have that one constant function there, where b is any number. Constant functions do not cross the x-axis. Their domain is all real numbers, and their range is b. So basically, the biggest thing that we have to understand here is anytime we have a y equals some number without an x value, we understand that that's going to be a horizontal line. So we understand, again, y is always going to equal negative 3. No matter what x value we have, we know y is always going to be negative 3. So the way that I have students graph that is go to y equals negative 3, put a point on each side of it, and then go ahead and draw your horizontal line straight across. Okay. The couple of things that they say there is that this is not going to have an x-intercept. And if you notice that, that is true. Has a y-intercept at negative 3, but no x-intercept. So a couple other things we need to quickly see. That this has no x value, which means that it has no slope. So we have to quickly analyze that and realize it's a horizontal line. Okay, go ahead and try guided practice 3A and 3B. Okay, 3A, pretty straightforward. Again, y equals 5. I know that that's a horizontal line. So I put that y-intercept at 5. I put a point on each side to balance it out and then drew that line. 3B is a little bit different because there's a 2 attached to that. Remember, we're still dealing with slope-intercept form, which means that y has to be completely by itself. So I went ahead and solved for y and divided that 2 over. So I know that y equals 1/2. So as tiny as it is, I put a point at the y-intercept 1/2, put a point on each side, and drew that straight line. Okay, so when you see y equals just one constant number, we know it's a horizontal line. Now let's look at vertical. It says vertical lines have no slope, so equations of vertical lines cannot be written in slope-intercept form. There are times when you will need to write an equation when given a graph. To do this, you're supposed to locate the y-intercept and use the rise and run to find a point on the graph. Then write the equation in slope-intercept form. So this last paragraph actually deals with this next example. We will deal with vertical lines later. So don't think that we're skipping that. That will be in another section. Right now we're focusing on horizontal lines. But let's go ahead and look at this. It says which of the following is an equation in slope-intercept form for this line shown. So now we're working backwards. Okay, again, the two things that we know that we have to find are the y-intercept. So I'm going to look straight down here, and I know this right here is my y-intercept. Okay, what is that? That is 1. So y-intercept, 1. Now I have to figure out my slope. Okay, so from that point, again, how far did we go up and over or down and over to get to another nice point that crosses an integer line? So this point right here and this point, we can go ahead and compare. Again, I'm going to look at my skateboard real quick. It's going downhill, so I know that this is a negative value. So I start from my left point, and I'm going to figure out how I got from there to this point. Well, it looks like I dropped 1 and I ran 3. So again, dropping is a negative, and then I ran, which is positive. So my slope is a negative 1/3. And a lot of times I put that negative on the 1 just to kind of remind myself that that means that I'm going to drop. But maybe the better idea is to put it out front to understand that that whole slope is negative. Okay, so I know that my slope is negative 1/3. I know my y-intercept is 1. So writing that as an equation, slope times the value of x plus that 1. And which one looks like that? C. Okay, so again, work backwards. Look at the clues. Where does it cross the y-axis? And then from that point to another point, how far did you go up and over or down and over? And again, what points do you look for? The ones that are an actual integer. These points in here do not work because the y values are fractions. You need both the x and the y value to be a nice whole number or a nice integer. All right, go ahead and try that for guided practice 4. Okay, y-intercept is down here at a negative 1. Slope from there is positive because my skateboard is going uphill. So I found 2 nice points to compare. Looks like I went up 1 and to the right 4. So there's my rise over my run. So I have a slope of 1/4, y-intercept of negative 1, which means I'm subtracting 1 from it. Okay. All right, story problems. Looking at this, we're supposed to use the information at the left about high school sports. We're supposed to first off write a linear equation to find the number of girls in high school sports after 1997. And it says in 1997, about 2.6 million girls competed in high school sports. The number of girls competing in high school sports has increased by an average of about 6/100ths of a million per year since 1997. Okay, so we're supposed to write an equation that represents that. Well, let's go ahead and look at the clues. Anytime we see that per year, we know that we're dealing with that slope because it's increasing that much per our x value, which is our year. This is our starting point. In 1997, we started with 2.6 million girls. So we know that that's going to be our intercept. Okay, so we're going to write a linear equation. Let's deal with participants. I don't really want to say girls. Participants and years. So participants is P, years is Y. So the participants are 6/107 million per year plus the 2.6 million that we started with. So P equals the 6/100ths per year plus the 2.6 that we started with. Okay, now we're supposed to graph that equation. Going to be a little bit tricky with the numbers that we're dealing with, but let's go ahead and just do our years as 1. And we can get up to 10. And again, these are dealing with years. Participants depends on which year we're looking at. Okay, we know that we have to start with 2.6, so we might as well just go by 5/10. So there's 1, there's 1.5, there's 2, 2.5. This is getting kind of ugly, so I'm just going to stop at 3 because my handwriting is terrible. Okay, so this is where it might be a little bit tricky to use our slope-intercept form clues. We do know that we started with 2.6, so I'm going to go ahead and put in that point that I know I started with 2.6. It's going to be kind of hard to go up 6/100ths and over, so we might as well plug in another point. Let's go ahead and figure out how many participants we had after 10 years, because again, we only need 2 points in order to graph. So I'm going to figure out what year 10 was. That way I have another point that I can compare. So participants after year 10, okay, is going to be 0.6 more. So I know after year 10, I have 3.2. So that kind of helps me out. So after year 10, I'm going to go up to, here's 3. 3.2 is going to be about here because I was going by 5/10. Okay, so again, another trick. If we're dealing with some pretty crazy numbers where it's really hard to see what the slope is and it's not in standard form, we might have to plug in and solve. Use that y-intercept at least, but this is what our graph is going to kind of look like. Okay, so we graphed our equation by just plotting another point to help us with it. Now we're supposed to estimate the number of girls competing in 2017. Okay, well, I don't see 2017 down here. But what we were looking at, again, here's our clues, after 1997. So our 0 year was 1997. So how many years later is 2017? 20. So 20 years later. Okay, so how do we do that? Well, up here we plugged in 10 years later. So now we're just going to plug in 20. So our participants are that 6/100ths. Now we're multiplying by 20 plus that 2.6. So we have 1.2 plus 2.6. So participants in 2017 is going to be 3.8 million. Okay, a little bit hard to see on this graph. Remember during our intro, it was really easy just to go over there and plot it. Again, understand what kind of problem it is. If we're dealing with some pretty small numbers or some pretty crazy decimals, plugging in and solving might be the best answer. So 3.8 million girls is what we have. Looks like we're down to one more guided practice, so go ahead and try this one, and then I'll put up the answer. Okay, a bit different here because they're selling sandwiches for $5 each, but they bought $1,160 in ingredients. So they're already, to start with, $1,160 in the hole. I apologize, this graph didn't work, so I had to change the y-axis because our y-intercept actually starts down in the negatives, that we're $1,160 in the hole. Realizing that it's really hard to go up by 5 on here, so slope was a little bit hard. So I plugged in 500. 500 sandwiches, they would be at $1,340 in the black. So we do have a positive number there. Okay, dealing with sandwiches and the profits. So sometimes understanding how to deal with that graph is a little bit tricky. Sometimes how to deal with how do I graph it is a little bit tricky. Again, pretty big numbers, pretty small numbers, go ahead and just plug something in and solve. C, find that total profit. If 1,400 sandwiches were sold, that's just a plugging in and solving that we should get 5,840. Biggest thing out of this is to understand that this is written in slope-intercept form. This is our y-intercept, which is where we start. Our slope is how much we rise or run, or drop and run from each one of those. So you should be ready for the assignment for this section.